In this lecture, we will learn about the prototype design pattern and how to implement it in Python. Prototype is a creational design pattern. It hides the complexity of making new object instances. We copy an existing object instead of creating a new instance from scratch. When do we use the prototype design pattern? We use this pattern when our code should not depend on the concrete objects that you need to copy. We also use prototype when we want to reduce the number of subclasses that only differ in the way they initialize their respective objects. To implement the prototype design pattern, we create a prototype interface and declare the clone method inside of it. A prototype class must define an alternative constructor that accepts an object of that class as an argument. We can optionally create a central repository to store frequently used prototypes. Let's look at the pros and cons of using the prototype design pattern. The advantages of using the prototype design pattern are that you can clone objects without coupling their concrete classes. You can get rid of redundant initialization code and replace it with pre-built prototypes. You can produce complex objects more conveniently. And you get an alternative to inheritance when dealing with configuration presets for complex objects. The drawback of using the prototype design pattern is that cloning complex objects that have circular references can be tricky. Let's learn how to implement the prototype design pattern in Python. Up at the top of the code, we will type from ABC import ABC, abstract method. We will also import the copy module. Next, we will create a class named courses at Udemy, which extends the ABC class. Inside of this class, we will implement the init function, which will take in the self parameter. Inside of this function, we will set self.id to none and self.type to none. Then we will create a getType function, which will take in the self parameter and return self.type. Next, we will have a getID function that takes in the self parameter and returns self.id. After that, we will create a setID function that takes in two parameters, self and id, and sets self.id to the id passed into the function. Finally, we will create a clone function that takes in the self parameter and returns copy.copy with self passed in. Then we will create a class named P that extends the courses at Udemy class. Inside of this class, we will define the init function. Inside of this function, we will call super.init and then set self.type equal to programming courses. Then we will create a class named A that extends the courses at Udemy class. Inside of this class, we will define the init function. Inside of this function, we will call super.init and then set self.type equal to art courses. After that, we will create a class named courses at Udemy cache. We will create a cache variable and set it equal to an empty dictionary. Then we will create a getCourse function that takes in a parameter named id and uses the static method annotation. Inside of this function, we will create a variable named course and set it equal to courses at Udemy cache.get with id passed in as the first argument and none passed in as the second argument. Then we will return course.clone. After that, we will create a load function that uses the static method annotation. Inside of the load function, we will create a variable named programming and set it equal to a call to our p function. Then we will type programming.setID and pass in the string 1. Next, we will set the courses at Udemy cache at the programming ID equal to programming. Then we will create an art variable and set it equal to a call to our a function. Then we will call art.setID and pass in the string value 2. Finally, we will set the courses at Udemy's cache at the art ID equal to art. Time to test our code. First, we will call courses at Udemy cache.load. Then we will create a variable named programming and set it equal to the result of a call to courses at Udemy cache.getCourse with 1 passed in. Then we will print programming.getType to the console. After that, we will create a variable named art and set it equal to courses at Udemy cache.getCourse with 2 passed in. Then we will print out art.getType. When we run the code, you will notice that the course types were printed out based on the IDs we passed in when retrieving the cache data, meaning that our code worked. In the next lecture, we will learn about the singleton design pattern and how to implement it in Python.